All right, hopefully we're back. That cut out for a second, which was not the best. But hopefully we are back in action. So that first one was a good review of probability. And now let's talk some stats. So like I was saying before, for stats, most of what you need is normal distributions, 95% confidence intervals. And beyond that, it's really just sort of decision making with being, statistically sound thinking. So let's start with this first one. I just finished inventing a lemon juice concoction that I believe will help settle the stomach of those complaining of acid reflux disease. What can I do to test this? How would I go about testing it? So I want to show that this causes something else, right? So anytime we're talking about causation, you should automatically be thinking about an experiment, right? And for an experiment, I mean a controlled experiment. So here's what you would need to say in this. You would need to have two groups separated. You would need one group that gets the lemon concoction. And this should be two groups of people with the disease. And then one group that gets no lemon concoction. And this, remember, is your control group. And you want to see if group with lemon concoction has significant changes. And remember, when I say significant, I mean statistically significant, right? So you would write that out in a nice sentence. We're kind of zooming through this, but that is our goal there. All right. Let's do some more. Heights of AKC registered male Labrador retrievers are normally distributed with a mean height of 23.2 and a standard deviation of 1.3. The percent of registered males whose heights are between 22 and 25 to the nearest tenth is what? So let's think about this. I've got my little bell curve. My mean is at 23.2. So I'm going from just below the mean to just above it. I'm going in here from 22 to 25. So I'm going to put this into my calculator. So my lower is going to be 22. My upper is going to be 25. My mu is 23.2. And my sigma is 1.3. So I'm just typing that into my calculator exactly that way. Remember, if you want me to update your operating system, I can do that. You just need to leave me your calculator for a couple periods when I'm not teaching. And so that would give me 73.9 about-ish percent. Okay, next one. Lifespan of Duracell battery is approximately normally distributed with a mean of 110 and a standard deviation of 4.8. I select a random AAA battery from the Duracell company. What's the probability that the battery will last more than 120 hours? So that's here. I'm looking for a probability of more. So my lower is 120. My upper is infinity, which I'm just going to do 9 repeating. And my mu is 110, and my sigma is 4.8. So again, I'm just going to put those into my calculator under normal distribution. So 120, and then a lot of 9s, and then 110, and then 4.8. And that comes out to be 0.0186, which is that. Okay. Let's look at the next one. A whaler caught a great white shark accidentally in his nets. The shark was so large, he first thought that it was a small whale. Before he realized the shark, they weighed it and found that its weight was 2,700 pounds. The whaler looked and found that an average great white weighs in the 19-20 pounds with a standard deviation of 320 pounds. Ms. Karat's family just added a full-grown Great Dane, taller than her. The average weight of a Great Dane is 165 with a standard deviation of 5.2. How much would her dog have to weigh, rounded to the nearest tenth, to be in the same percentile as the 2,700-pound shark? So let's figure out the percentile the shark's in. So when we talk about percentiles, we're saying, okay, 2,700, what percent is less than or equal to that? So this would be 2,700. And then I would say, okay, this is, that's my upper. My lower is negative infinity, right? And my standard deviation is 1920. And my sigma is 320. So I'm going to put those in my calculator. So distributions, normal distributions. I'm going to put in my negative infinity-ish thing. And then 2700. And then 1920. And then 320. And so that shark is in the 99.26053 917 percentile. Okay, that's his percentile. Now, what weight of the Great Dane would be in that same percentile.